Assalamualaikum and hi. Today I'm going to present you about software quality management system. So, what is software quality management system? Software quality management system is management process that aims to develop and manage the quality of software in such a way as to best ensure the product meets the quality standard. Software quality management requires software to be tested before it's released to the market, and they do this using a cyclic process-based quality assessment in order to review and fix bugs before release. Software quality management system. So this is software triples constraint. It consists quality, budget, and time in software development. The schedule becomes the most important aspect, and cost of delays outweigh the benefit of producing software of low defect density. A limited budget assigned to the quality plans hamper the quality assurance team from carrying software works product. Software quality. Software quality perception. The quality of software is strictly linked to the notion of software defect and defect density. Software defect can be defined based on different views and perspectives. However, it is commonly agreed that a software defect in any flaw present in the software that prevents the normal software execution. So this is the formula of defect density matrix. Cost of software quality. The term cost of software quality describes the trade-off between delivering high-quality software and the cost associated with it. Software quality and profit. The relationship between software quality and profit is linear at the beginning, as implementing practice and technique removes defect and improves software quality. So this is the relationship between the quality and the profit. Quality system model. The optimal use of quality assurance practice and performing the required trade-off process between the software triple constraint is regression-based. So this is workflow of quality model. The next step of the categorization process is the constraint check. Once constraints have been determined, they go through the optimal solution determined process. The optimal solution found will be based on two or more of the software triple constraint: cost, quality, and schedule. Software model categorization. So this is the function of software quality model. The project deliverable of each phase in the SDLC can be broken down into works products. Having the risk level determined, each works product of software development phase is categorized based on the defined set of risk level. Let's see the set of all categories that are used in the domain for which the software is being developed. So this is the size of output phases. This is the phase of categorization process. The categorization of phase deliverable work products depend on the project manager inside the QA team consideration for the deliverable itself. Categorization scenario. The process of categorizing software phase into works product is independent of the software size and risk the level defined. Data repository of QA activities. The application of this approach for many projects following the same software development process enables the QA team to build up the data repository of defect reports. So this is the work products input table. Having completed the data input process, the data analysis process starts by grouping the dependent variable. The QA practice divided by 3 database tables. This is the proposed regression analysis. Formal model. Following the SDLC approach being used by the software development organization. Model cost aspect. Number 1. Number of defects. Number 2. Execution cost and effort. And for number 3, cost of escape defect scenes. D is QA practice and phase association. The mechanism of our models works by associating QA activities carried out during the development activities of SDLC phases. This association mechanism should quantify the impact of all escape defects in terms of the estimation cost associated with their defect removal activities. Refer to this value in our model as the escalation factor of defect. D is the number of estimation defect. D is the cost of escape defect. Execution time and effort. The execution time is defined in our model as the time required to run a QA practice in a software artifact in order to detect the removed entry. D is the execution effort. This is the execution effort formula. So this is the safe cost of QA activities and its formula. This is combination of QA practice. As an example, the testing team choose to apply QA practice into a specific work product. Assuming that the size of the work product is 10 FP, that means the work product is estimated to be injected with 10 software defects. Here is the estimation result of the activities. In order to reduce the impact of these 3 escape defects, the testing team decided to retest the same work product using another QA practice. Based on the value of W and the D are the QA practice, 50% of the testing team will expect the verification process. This potential scenario is well thought about in our research, and we tried to tackle it by devising new variable to calculate the probability that a QA practice. D is the lambda variable association. D is the combination variable of applying the practice. Return on investment. Defect detection and removal activities are considered to be an investment, especially for profit-based software development organizations. As our focus in this research is mainly on the second aspect of the cost. First of all, we recall the function that we use in our model and consider our model component. These functions are: in order to calculate the numerator for our ROI equation, we use that accordingly, substituting the two values of our ROI equation here. By generalizing the previous equation to the whole work production, we can calculate the relative of all QA time applied to work product by summing all variables as shown as below. That's all from me. Thank you for watching.